Okay, good day everyone. So let us have this session. So today we are going to continue on compound interest problems. So similar objective to what we have gone through. So first you memorize formulas involving simple and compound interest as well as simple discount. And then construct cash flow diagrams. So this is essential for your problem solutions, and then of course solve problems involving interest, inflation, and discount. So let us have another example here. At a certain interest rate compounded semi-annually, 5,000 pesos will amount to 20,000 pesos after 10 years. What is the amount at the end of 15 years? So we put that into cash flow diagram with periods of 5-year intervals here. So of course, at the beginning of the period, there will be a principal of 5,000 and it will amount to 20,000 after 10 years according to the problem. So with that, you can forward 5,000 into the future. We'll just say that 5,000 multiplied by finding F10 given P at R% at N of the 10th year. So of course this will be applied on that. Of course you can also apply the other formula referring to the F, finding F given P or finding P given F. So the any of those formula. So in this case I'll just use this formula. F is equal to P times 1 plus I raised to 10, and then the future is actually F10 on that, wherein I is compounding semi-annually, so that will occur twice a year. So your nominal rate of interest will be divided by 2, or that is 0.5 of R. And the number of interest period is equal to twice multiplied by 10-year. Okay, so it will occur twice a year times 10, that will be equal to 20. Now putting all of those figures on the formula, you can see that the unknown here in the equation is R. Okay, of course simplify mo muna, and then we raise all of the expression or the equation with 1 all over 20 so that we can get rid of raised to 20 there. Okay, so performing that on the right or on the left hand equation will give us 4 raised to 1 over 20, that is 1.07177, and of course the right hand equation will just eliminate raised to 20. Okay, so meaning 20 over 20, or that will be raised to 1. Okay, and then transpose 1 to the other side to become difference of 0.07177 is equal to 0.5 of R, and then divide both sides by 0.5 will arrive at 0.1435 or 14.35%. So R, which is 14.35%, will be used in calculation of our future worth further move to the 15th year. Okay, so the same procedure, we're gonna forward F10 to F15. So with that range. Yung 10 mo, ito na magiging present, and yung 15 will become the future of your equation. So we use the same formula. Okay, F15 this time will be the future, and F10 will be the present value or the principal. Okay, so we just substitute all the given here. So notice here that our n is 5, because the difference between the 10th and the 15th is 5 years. So there will be a 5-year interval on that timeline. And then just the same, we multiply that by 2 because it is occurring twice a year. That is semi-annual. So simply calculate, we get the value of 40,000 pesos. Okay, so that's it for this problem. So as an alternate solution, you can actually make use of the present up to the 15th year instead of using the F10. You can always use the principal or at the present worth or at the 0 year, so that you can compute N15 is equal to 2 by 15. So twice a year at 15 years is equal to 30. So we forward that 5,000 by multiplying it by compound or the single payment compound amount factor. So we say that 5,000 times finding F15 given P at 14.35% at 15 years. So N15 is actually 15 by 2, that is equal to 30. So just the same formula. So we'll put that in to that formula, all of the given. So we will arrive at the same answer, 40,000 pesos. Okay, moving on to the next problem. So 500,000 was deposited at an interest of 6% compounded quarterly. Compute the compound interest after 4 years and 9 months. So ano yung 500,000 dito? It is actually the present worth because it was deposited. So we put that into cash flow diagram. Of course, may butal between 4 and 5 years because we have 9 months on that. And we take note that the compound interest is compounding quarterly actually. So 500,000 is deposited and then brought to your future. So this is a compound interest wherein the interest is just the difference between the future and the present worth. So 500,000 will be multiplied by F given P, 6% at N. And for 6% compounded quarterly interest, we compute for the number of interest period will total to. First, it will occur 4 times a year. So there are 4 years here, buo na 4 years. So 4 times 4, and then we add 3. So where did we get? We get the 3. So quarterly occurs every 3 months. Therefore, 9 months divided by 3 months, that equates to 3. And then don't forget also to divide your nominal rate of interest 6% to 4 because it is occurring 4 times a year. So 6 all over 4, that is 1.5. So we yield to 6% over 4 is equal to 1.5% for our I. So we'll just put that into the formula to solve for the future. So we denote that 1 plus I raised to N is finding F given P at 1.5% at 19. So we substitute the values, we get 663,475.37 pesos. So with this, we can subtract or get the difference between the future and the present, and that will be the interest. That will equate to 163,475.37 pesos. Okay, so that's it for this problem. So next, 200,000 pesos was deposited for a period of 4 years and 6 months and bears an interest of 85,649.25. What is the interest rate if it is compounded quarterly? So we are actually getting here I if it is compounding quarterly. Now 200,000 pesos is again the present worth, and the interest is 85,000. Knowing your interest and the principal, of course, we'll just add that will be your future, diba? Future worth. So this time we have a cash flow diagram involving 6-month interval that is between the range of 4 to 5 years. So we put 200,000 on the principal. We put that on the future. Okay. So we'll just add. I-add mo lang yung 85,000 na interest to the principal. That will be your future worth. Okay. And we got that notation, 200,000 times finding F given P, 6%, N. And again, for 6% compounded quarterly interest, because this is an interest of 85,000, just the same kanina, we just have to multiply 4 years at 4 occurrences per year, and then add 2. Where did we get that 2? Quarterly occurs every 3 months. Therefore, 6 months all over 3 months is equal to 2. So just the same, our percent is divided by 4 because that is occurring 4 times a year. So we now apply the formula F is equal to P 1 plus I raised to N by substituting also the given here, then the notation. So we are finding here the nominal rate of interest R percent. Okay. And we divide first the left hand side of the equation and the right hand by 200,000. Okay, so it becomes 1.428 on the left hand side, and then 200,000 will vanish or will just equate to 1 there. And then yung natira is 1 plus R over 4 raised to 18. And then we will eliminate radical exponent here by raising it by 1 all over 18, raised to 1 all over 18. Okay. So 1.428 raised to 1 all over 18 will become 1.02. So we will get rid of raised to 18 on the right hand equation. Then transpose mo lang yung 1 and then multiply it by 4. So R is equal to 8%. So that is 8% compounded quarterly. So that will be the nominal rate of interest of this problem. Okay, so moving on to the next. If a sum of money triples in a certain period of time at the given rate of interest, compute the value of the single payment present worth factor. So this is our expression for the single payment present worth factor. Okay, wherein the formula, yung future mo is nag-triple yung P. Okay, the principal tripled. Okay, so that could be expressed in 3P. Basically, we can cancel P on the both sides of equations, and then we come up with that expression. Of course, we are getting the single payment present factor, so we need to reciprocate everything. Okay, so the answer here is 1/3. Okay, so moving on to the next. how many years will 100,000 pesos earned a compound interest of 50,000 pesos if the interest rate is 9% compounded quarterly? So we need to determine the number of years this 100,000 will bear an interest of 50,000. So dapat maging 150,000 yan at a certain year. Okay? At a certain number of years. So let us assume that 100,000 is actually the present value, and then would become 150,000, okay, with the interest on it, no? So that year we do not know. And for 9% compounded quarterly interest, 9% will be divided by 4. That would yield to 2.25%. And then let x, the number of years, putting up that formula. Okay, so substitute 150,000, 100,000, and then 1.0225 or 1 plus I raised to 4 times x. So 4 times x. 4 times a year multiplied by the number of years, x. So before we are going to have the logarithm on both sides of the equation, let us divide that by 100,000 so that we can have 1.5 on the left hand side, and maiiwan yung ma-isolate yung 1.0225 raised to 4x. So this time we are going to log the whole equation, so both sides of the equation actually, so that we can bring down 4x. Okay, and then we perform quotient of the two logarithm functions, and then divide both sides by 4 so that we can get the value of x. That will be equal to 4.56 years. Okay, so next problem, how long will it take money to double itself if invested at 5% compounded annually? So again, let x the number of years. So we use the same formula where in the future we express p into 2p because p will be doubled on that future, and then eventually p will cancel on both sides of the equation. Again, the logarithm function, our purpose here is to bring down x because x here is the unknown, and then perform quotient of the two logarithmic functions. So that's it. X will be equal to 14.21 years. Okay. So continuous compounding. So this is actually a new, not so new topic, but there will be some variation on the expression or the formula involving compound interest. So this time it is assumed that cash payments occur yearly. It is once a year, but the compounding is continuous throughout the year. So our formula is involving f and the present worth just the same, but we'll be having here the constant e raised to r times n. So p here is just the same present worth, and the future worth is f. N is the number of years, r is the nominal rate of interest, and e is the constant equivalent to 2.718828. Okay. So remember that the natural logarithm of that function will equate to 1. Okay. And e raised to rn is what we call compound amount factor or compounded amount factor. So what about its effective rate of interest? Kung yung dati meron tayo nito, effective rate of interest 1 plus I raised to m minus 1. This time, yung 1 plus I raised to m, palitan mo lang ng e raised to R. And that will be the effective rate of interest for continuous compounding problems. So let us have now the example. A nominal interest of 3% compounded continuously is given on the account. What is the accumulated amount of 10,000 pesos after 10 years? So basically, 10,000 pesos is what? Present or future? Of course, is present. Okay. Then the number of years, 10 years. We'll just have to directly substitute in the formula. Okay. Then we will have this value. F is equal to 13,498.6. Next. If the nominal rate of interest is 3%, how much is 5,000 pesos worth in 10 years in a continuously compounding amount? So, anong unknown dito? Is it present or future? Of course, that is future. So, just the same formula. P here is 5,000 or the present value. N here is 10 years. Then the R is 0.03. So, by direct substitution, we can get the value of F is equal to 6,749.29 pesos. So next, compute the effective annual interest rate which is equivalent to 5% nominal annual interest compounded continuously. So this time we are going to use the effective rate of interest formula. Okay. So we just substitute nominal 0.05, no? And then the effective rate of interest will be equal to 0.05127, or that is 5.13%. Okay. So next problem. Find the required years for a sum of money to triple itself at 5% per annum compounded continuously. So this time we are going to determine N. Okay. So anyway, say X is the number of years. May formula lang naman tayo dyan. And remember, yung triple, ibig sabihin yan, 3P. Or P will become 3P after a certain number of years, X. So just the same, we will cancel P on both sides of the equation. And then apply loan. Okay. Loan, because loan of E is equal to 1. And so that we can also bring down 0.05x. And then perform here. And loan of E is equal to 1. Just perform the natural logarithmic functions and then solve for x. Now x is equal to loan of 3 all over 0.05. That would yield to x will be equal to 21.97 years. Okay. So how about this problem? A man wishes to have 40,000 pesos in a certain fund at the end of 8 years. How much should he invest in a fund that will pay 6% compounded continuously? Just the same formula. Ano yung 40,000 pesos? It is actually the future worth, because that is the aspiration of the man after the end of 8 years. So magkano yung dapat niyang i-invest? So R here is 6%. So we will substitute on the formula. For P is the present worth he needs to invest. So yan, 24,751.34 para magkaroon siya ng 40,000 after 8 years if it is compounding continuously. Okay, so I think that ends our session for today, and with this, thank you for listening and have a good day.